All right, in section 4, we're going to look at some properties of logarithms. So when you have logarithmic expressions, we can use these properties to simplify them or to make more complex expressions a little simpler. So the first one we're going to talk about is what's called the logarithm of a product. And that's when you have the log of two things multiplied together. So in this example, log base b of xy. If you have that, you can write this as log base b of x plus log base b of y. So a couple examples. Let's say I have the log. Let's just do a natural log. Natural log of 2x. Now that is two things multiplied together. That is a 2 and an x. So I can write this as two logs added together of those two things. I'm not sure why I wrote the x first. It could be the 2 first. Does not really matter because addition is commutative. The other thing you can do is you can put things together. So if I have the log, let's just do a common log. Let's say I have the common log of 3 plus the common log of 7. Then I can write this as the common log of 21 because I'm simply multiplying that 3 and the 7. So if you ever have those, you can always put them together or break them apart. Second property we'll look at is logarithm of a quotient, and that's when you have two things divided. So this is log base b of x divided by y. Of course, y can't be 0. And of course, the whole quotient has to be positive, because remember, anything put into a log has to be positive. But if you have a quotient of these two things, then you can simply write it as log base b of x minus log base b of y. So if I have, say, the natural log of 7 over z, then I could write this as the natural log of 7 minus the natural log of z. Now in this case, the order does matter, because subtraction, you can't just switch back and forth like you can addition. So in subtraction, it actually does matter. And same thing, if I had two things subtracted, let's say I had the log of x, natural log of x, minus the natural log of 9. Then I could write this as the natural log of x over 9. The last property we'll look at is what's called the logarithm of a power. These are our big three properties we use for logs. And this one's actually a really important one. It's kind of the most bizarre of the three. So it says log base b of x to the n equals n log base b of x. So an exponent inside an expression can be brought out front, and vice versa, a number out front can be brought as a power. So let's say I have the log base 4 of, say, y to the 1/2. Then I can bring that 1/2 out front and make it 1/2 log base 4 of y. Similarly, we could do the same thing. We could start with 1/3. We'll do natural log of z. And I could write this as the natural log of z to the 1/3. And recall from algebra, if you have anything to a fractional power, that's actually a root. So the natural log of z to the 1/3 can be written as the natural log of the cubic root of z. A couple other just comments, come on identities for logs, things that really we've seen before, just working with logs and knowing what the definition of a log is. The log of any base of 1 is always 0. This is probably the easiest property to understand, because if you remember the definition of log, it says b to what power is equal to 1. Well, the only thing raised to a power that will be 1 is 0. Anything to the 0 is always 1. So the log base b of 1 is 0. Similarly, for the next one, log base b of b is 1, and it's the same idea. B to what power is b? Well, b to the 1 is b. So log base b of b is 1. And finally, we have log base b of b to the n equals n. This is kind of a combination of this one and the logarithm of power, because I can bring this n out front and make it log base b of b. Well, we just said that log base b of b is 1, so this is just n. So let's look at some examples how we can use these properties of logs. So the first one says, what is the natural log of e divided by x? And I want to write it as a sum, difference, or multiple of logs. This is sometimes referred to as the breaking apart of a log. So you see here we have two things, e and x. They're divided. So if you remember from the previous page that logs of things divided is the difference of two logs. So I could write this as natural log of e minus natural log of x. But we can actually take this further, because if you recall, natural log means it has base e. So a log of any base that has the matching thing is always 1. So this would simply just be 1 minus the natural log of x. So we take the log and we break it into different things, hopefully that are simpler than the original. More terms, but simpler terms. Let's look at this one. We have log of x times the square root of x squared plus 1 with x greater than 0, because we don't want negatives in our log. So I actually have two things multiplied, because I have this x times this square root of x plus 1. And so how I'll write this is I'll write this as log of x plus log of square root x squared plus 1. Now, like we talked about on the previous page, roots can be written as exponents, and this is a very, very common thing to do in log problems. So what I'm going to do is I'm going to go ahead and rewrite the square root as a half power. So I'll write it as log x squared plus 1 to the half. And now the big benefit to doing this, now I can take that half out front. So we get log of x plus 1/2 log of x squared plus 1. Now don't try to go too far and do anything else, because this is all the further you can go, because this is a sum. There is no property that says log of two things added together. It's log of things multiplied, log of things divided. So let's look at this one. We have log base 2 of x squared over x minus 1 squared, x greater than 1, to preclude any negatives. So I would first see that I have two things divided, so I'll divide it into two logs by subtracting. So log base 2 of x squared minus log base 2 of x minus 1 to the second. Now again, for both these, I see that I have the 2 that I can bring out front. So I can bring this 2 out front here and this 2 out front here. So I can write this as 2 log base 2 of x minus 2 log base 2 of x minus 1. So those are some examples on how to break apart logs, where you're having one log and you're breaking them into smaller parts. The other kind of problem we will see is when we have several logs and we try to put them together. So essentially just the reverse of what we just did. So if we look at these two examples, we want to write these as a single log. So the first one says log base 2 of 4 plus 7 log base 2 of x minus half log base 2 of 5. Now the good news is the bases are all the same. So we always broke apart by addition, subtraction first, and then took powers down. So we kind of do the opposite when we're talking about putting together. So we'll take the powers that are out front and we'll take those to the top. So I'll rewrite this as log base 2 of 4 plus log base 2 of x to the 7th minus log base 2 of 5 to the 1/2. And again, 5 to the 1/2 is the same as square root of 5, so I'll make that change later. I can bring these two logs together because they're added, and two logs added together can be written as one log multiplied. So 4x to the 7th minus log base 2 of square root of 5. And now I have two logs that are subtracted, so I can write it as one log divided. So this is log base 2 of 4x to the 7th over the square root of 5. So I took several logs, 3 of them in particular, and I put them all together. Let's look at one last example. We have 2 log base 2 of x minus log base 2 of x squared minus 16 minus 2 log base 2 of x plus 4. So again, I have some powers up front. I have this 2 here, and I have this 2 here. So I'll write them accordingly. So this is going to be log base 2 of x squared minus log base 2 of x squared minus 16 minus log base 2 of x plus 4 squared. Now I can start with any of them that I want, but I'll just start with the first 2 to put together. They are subtracted, so when you subtract, you will write it as division. So this would be log base 2 of x squared over x squared minus 16 minus log base 2 of x plus 4 squared. Now we have subtraction again, so we're subtracting a fraction. We're dividing a fraction by a single denominator. Now the key thing is, if you're subtracting, you can just put whatever is in the bottom of your expression and it'll work out. And if it's added, you just multiply it to the top. So I can write this as simply x squared over x squared minus 16, and then I'll just put the x plus 4 squared right next to it on the bottom. Now I can try to simplify this a little more. All the log properties are done, but I can factor. Just write it a little differently. I know this is difference of squares, x minus 4, x plus 4. And then we have x plus 4 squared. So now I see I have 3 of that factor. So my final simplified answer would be log base 2 of x squared divided by x minus 4 times x plus 4 cubed. Always a good idea to simplify, because sometimes things will cancel out. Sometimes things will come together like this one, just to make your answer a little nicer. So hopefully this is not too bad. If you have questions, please let me know on log properties.